Okay, checkpoint 14. We're going to start at question 10. So, triangle ABC has three medians drawn, segment AF, segment BE, and segment CD. The area of triangle ACD equals 17 centimeters squared. What can be said about triangle BCD, and then justify our answer? Okay, so the first thing, medians, is medians cut the opposite sides in half. So if we're looking at triangle ACD, and then we want to know about triangle BCD. We know that the median from C to D cut AB in half, so this segment and this segment are the same length. And then it is given that this is 17 centimeters squared in area. And the way I remember this is if I were to draw perpendicular straight up, straight over. So if I were to draw a rectangle that had this triangle within it, a rectangle has a perpendicular corner, and if you were to move that side length or to draw a perpendicular anywhere in this triangle, create the altitude, which is your height. This height would be the same distance as the side of the rectangle, no matter where I drew it. So if I were to draw triangle ACD's altitude, which is the height of the triangle, which can be outside of it or inside of it, it's just our height, and it's 90 degrees to our base. So if I were to draw this height, and this height, it's the same height. And the reason why I'm pointing that out is because the area of a triangle is 1/2 its base times the height. So if these two triangles have the same height, then the only thing that we need to show is that they have the same base so that they would have the same area. And that's already been shown because AD is the same length as BD because it's a median, because it was cut in half. So we know that triangle BCD is equal to the area of triangle ACD, and we know that because medians split the medians have an endpoint at the midpoint of each side of the triangle. So point D is the midpoint. That way we know each segment was the same. Question 9. Use the figure to answer the question. Given triangle ABC with segments AD congruent to DB and AE congruent to EC, you know that DE is blank, therefore BC is a blank. Okay, if we're looking for definitions, I'm going to be scanning for a picture that looks like this in our notes. Oh, look, that one looks like it. Mid-segment of a triangle. Okay, a line segment that connects the midpoints of two sides of a triangle. Okay, which is true. DE connects the midpoint D and the midpoint E. So DE is a mid-segment, comma. Therefore, BC equals blank. Well, BC is down here, so let's continue reading from our notes. Triangle midsegment theorem. If a segment is a midsegment of a triangle, then it is parallel to the third side and half of the length. So DE is half of the length of BC. So to find the length of BC, we would need to double DE. So doubling means to multiply by 2. So we're going to times 2 by 7.5, which is equal to 15 centimeters. And we're not going to write in centimeters because it's written right there. So it's 15 in length. Right, question 8 is the proof. Alright, D is the midpoint of segment AB. So I'm going to mark what that means. That means that AD is congruent to DE, or has the same measure. And E is the midpoint of AC, so that means A to E is the same length as E to C. And DB, right here, is parallel to CF. Okay, we need to prove that DE is parallel to BC, and that it is 1/2 of the length. So we're proving the mid-segment theorem. And if you notice in the notes, it has a partial of the proof. It has the part to prove that it's half of the length. So we can scan this as a reference if we need to. So let's go through and see if we can find our solutions with what's given. Okay, so I'm going to start at statement 3. Angle A is congruent to angle FCE. So angle A is congruent to angle FC. Is congruent to FCE. Right here. And you may be asking how. This line and this line was given that they were parallel. We have a transversal that crosses our parallel lines, which is AC, and we have alternate interior angles. Right there, alternate interior angles theorem. Then that means that angle AED and angle CEF right here, and AED, what kind of angle is this? They are going to be vertical angles, and the reason I know that is because we have an X right here, and in this X, angle AED is across from angle CEF. And that's how I identify vertical angles. Is anytime you have an X created by two lines that are crossed, vertical angles are formed, and they're the ones that are opposite sides. So these two angles would be vertical angles, and then the ones up and down would be vertical angles to each other. So blank 1 is going to be vertical angles. And then they state that the two angles are congruent because it's a vertical angles theorem. And now they're stating, if we look at reason 2, the statement is triangle AED. Triangle AED is congruent to triangle CEF. And we need to know why. What was given in there? So The first one that was given was angle A was congruent to angle FCE. So we have one pair of corresponding angles that are congruent. And then we had angle AED. We had another angle right here. Was congruent to CEF. So we have another pair of congruent angles. And then the statement 6 was CE. C to E. This segment is congruent to E to A. So what we have is an angle, a side, and an angle. We had an angle, a side, and the corresponding angle. So we have angle, side, angle, triangle congruence. And then reason 3 goes with our statement DB is congruent to FC. And we need to know why. And we need this because we need to be able to prove that the opposite sides of a parallelogram are congruent. There is our question 8. And then before we reach question 7, I'm going to share with you the 4th step from Marissa Peer's 5 steps to avoid rejection. First was thank you for stating that. The second is asking them to repeat it slowly. The third is asking, why would you say that? Are you trying to hurt my feelings? And the fourth is if they come back and say, well, yeah, I'm trying to hurt your feelings. The fourth one is stating out loud, that's not going to work because I'm not letting your opinion in. And so that's the 4th step, is just declining to let it bother you. So state, that's not going to work, I'm not letting it in. Okay, question 7. Use the information diagram and proof to fill in the blanks. Given D is the midpoint of segment AB, E is the midpoint of segment AC, and segment DB is parallel to segment CF, we need to prove that segment DE is parallel to segment BC, and that the length of DE is equal to 1/2 the length of BC. So if we look here, segment DB is congruent to segment FC. Is our we need our reason for that. And what I am noticing is in the segments above, I see AD right here, and I see a DA. That is the same segment. And then I'm seeing a DB right here, a DB right here, and I'm seeing the FC right here and right here. So we would have, if I were to write this out in a straight line, we have that, here, I'll show you which one. I'm going to write this one out. right here. We're starting right with this one. DA is congruent to FC, and then I'm going to link it with this one. AD is the same thing as DA. AD is congruent to DB. And so how did they come up with this statement? That DB was congruent to FC. This is the transitive property of equality because we have this link right here. The DA and AD is the same segment, but we have that DB is equal to it. We also have that FC is equal to it. So we can state that DB is congruent to FC. And I remember this by cutting out the middleman. DA is our equal linker. I don't know if that's proper English, but that's what I think of. This segment is our link. And if what we started with is equal to the link, and the link is equal to what we ended with, then we can take out that link and just say what we started with is equal to what we ended with. So, blank 1 is our transitive property. That means my blank 3 here needs to be transitive property for question 8. So question 8 is because our transitive property and it's the same reasoning as what we just stepped through because this is the exact same proof. And then statement 2, I'm curious, 12, DE is parallel to BC, definition of a parallelogram. Segment DE is parallel to BC, definition of a parallelogram. Because opposite sides would be parallel. And then we have blank 3, and I'm going to look to question 8 again because it's the exact same thing. It was for statement 16. So if I look at statement 16, DE plus DE equals DF. And they stated as the substitution property of equality. So, substitution property of equality. That is how I'm answering question 7. Now, if we did not know that, how would we fill in our blanks? Blank 2 would be filled in because opposite sides of a parallelogram are parallel, right there. And blank 3 could be filled in by the substitution property of equality because if we look right here, we have DE plus EF equals DF, and then we have DE, which is the same, and then plus DE, which is different. And the reason why it's called substitution is because of right here. They state DE is equal to EF, and so they just replaced EF in statement 15 with DE, and that's the substitution property of equality. And there's your help.